Double and triple bonding. When an element has 2, 3, or 4 unpaired valence electrons, its atoms will sometimes share more than one of them with another atom. Double and triple bonds between atoms are also possible. Okay, here is an example. Carbon dioxide. Carbon dioxide has one carbon and two oxygens. So I'm going to write the two oxygens, one on each side. Okay, and I'm also going to write the electrons around the different atoms. So carbon has a total of 4 valence electrons and oxygen has a total of 6 valence electrons. And out of these 6 valence electrons, there are 4 electrons which are going to exist as lone pairs. Now, what are lone pairs? We say this as lone pairs. Lone pairs are electrons which are not going to participate in bond formation. So they are also called as non-bonding electrons. They do not involve in forming bonds at all. They just wanted to exist on the elements. Non-bonding electrons. Okay, so when you draw the Lewis dot structure, the total number of electrons around the atom, total number of electrons, which is actually the number of non-bonding electrons and the bonding electrons, should be equivalent to 8. So after you draw the Lewis dot structure, when you count the total number of electrons that an atom has, it should be equivalent to 8. Okay, now let's see. Carbon can actually form a total of 4 bonds, because when you look into the structure, look into the Lewis dot structure for it, it has 4 single electrons, therefore it should form 4 bonds. Now let's see how these 4 bonds are formed. Okay, so now you can see that there is 1 electron on oxygen and 1 electron on carbon, which is going to be combined together to form 1 bond. Okay, and the same thing holds good for the other side as well. Okay, now these electrons right here, okay, they're going to go hop in one on each side. Okay, so this electron is going to come up here, this electron is going to come up here. Okay, so and similarly this oxygen is going to come up here and this oxygen is going to come up here. When that happens, okay, now let's see, this electron is going to come up here, this electron will come up here, this will come up here, this will come up here. When that happens, you will actually form a double bond between carbon and oxygen. So now you have your Lewis dot structure for carbon dioxide. So now let's count the total number of electrons around each atom in the molecule. Okay, so let's take carbon. So here is carbon. Okay, remember it has a total of 4 bonds. So for each bond, there are actually 2 electrons. For 4 bonds, it should have a total of 8 electrons around it. Okay, so it is satisfied. Now let's go on to this oxygen. This oxygen has a total of 2 bonds. Okay, therefore it's going to be equivalent to 4 electrons, but it also has got a total of 4 electrons, which is actually existing as electron pairs. So 4 plus 4 equals 8. And the same thing is going to hold good for the other oxygen as well. Okay, so this is how you do the Lewis dot structure for a molecule which has double bonds. Okay, so here is an example where a triple bond occurs. Okay, if you want to draw a structure between 2 nitrogens, okay, it's actually going to form a triple bond. But how does this triple bond occurs? So first you will draw the Lewis dot structure for nitrogen. So as you can see from the Lewis dot structure, it is actually going to have 1 lone pair of electron and then 3 single electrons, and these 3 single electrons can actually form 3 bonds. Okay, so basically each of the so you can actually draw it like this. You can put all the 3 electrons on one side, 3 electrons on one side, and remember this is a lone pair, and these 3 electrons will actually form 3 bonds with the 2 nitrogens. Okay, and therefore here is the Lewis dot structure for nitrogen. Okay, and it doesn't really matter where you actually put these lone pairs, as long as it is situated on nitrogen, it should be good. So you can put it here or you can put it here, it doesn't really matter. As long as it has a lone pair of electrons, it should be fine.